Hi everyone, welcome to the channel. In this video, we will see the answers to the week 4, assignment 4 for the NPTEL course Data Science for Engineers for the August 2023 session. So let's get into the video. First question is, let f of x is equal to x cube plus 3x square minus 24x plus 7. Select the correct options from the following. So they are asking the value of x at which will give the minimum for f of x and what is the maximum value for f of x. So the answer to this is x is equal to 2 will give the minimum for f of x and maximum value for f of x would be 87. Next question is, find the gradient of f of x comma y is equal to x square y at x comma y is equal to 1 comma 3. So here the answer to this is gradient for f of x comma y is 6 and 1. Next question. Find the Hessian matrix for f of x comma y is equal to x square y at x comma y is equal to 1 comma 3. So here the answer is 6, 2 and 2, 0. Next question is, let f of x comma y is equal to minus 3x square minus 6xy minus 6y square. The point 0 comma 0 is a saddle point or a maxima or a minima is the question. So here we would be finding the derivative of first derivative of f of x. We'll be differentiating f of x comma y with reference to x. Let's call it as fx. So fx will be, since f of x comma y is minus 3x square minus 6xy minus 6y square, fx would be minus 6x minus 6y. And when we differentiate that again with reference to x, fxx would be minus 6. Similarly, when we differentiate f of x comma y with reference to y, we would be getting, whenever we differentiate f of x comma y with reference to y, we would be getting minus 6x minus 12y. And then when we differentiate f of y again with reference to y, we'd be getting minus 12. And then when we find the partial derivative of f with reference to x and y, we would be getting, when we differentiate fx with reference to y, already we got fx as minus 6x minus 6y. When we differentiate it with reference to y, we would be getting minus 6. So we will be calculating the value of d, which is given by fxx into fyy minus fxy the whole square. So fxx is differentiating fx with reference to x. And fyy is differentiating fy with reference to y. And when we substitute all of the values, we'd be getting fxx is minus 6 and fyy is minus 12. We will be multiplying both of it and we'll be getting 72. And fxy would be plus 6 the whole square, so which would be 36. So d would be 72 minus 36, which is 36. So the constraint is we need to find whether the point 0 comma 0 is a saddle point or a maxima or a minima. So to find that, we are checking where if the value of d is greater than 0 and the value of fxx is greater than 0, then f of a comma b is a local minima. Here our value of d is greater than 0, that is 36, and fxx value is minus 6, which is less than 0. If the value of d is greater than 0 and fxx is less than 0, then f of a comma b is a local maxima. So here the answer is local maxima. Next question is, for which numbers b is the matrix A is equal to 1, b and b9 positive definite. So to find positive definite, we can do the determinant test. So when we do the determinant test for the matrix 1b, b9, we'd be getting 9 minus b square. And for it to be positive definite, we need 9 minus b square greater than 0, which means 9 is greater than b square or b square should be less than 9. So the options, out of the options, the constraint which satisfies this b square should be less than 9 is b should be either equal to 0 or b should be less than 3. So the first option minus 3 less than b less than 3 is the correct answer. Next question. Consider f of x is equal to x cube minus 12x minus 5. Which among the following statements are true? So to find that, So we have to find whether f of x is increasing in which interval and f of x is decreasing in which interval. So to find that, we need to differentiate f of x. We need to find the first order derivative for f of x. When we find the first order derivative for f of x, let's denote it as f dash of x. So f dash of x would be 3x square minus 12. So this would mean 3x square is equal to 12 and the x square would be 12 by 3, which is equal to 4. So x would be plus or minus 2. So when we plot it in an interval ranging from minus infinity to plus infinity, and plot minus 2 on one side and plus 2 on another side, and we take one of the values in the interval minus infinity to minus 2, let's say minus 3, and use it in the equation, we would be finding that in the interval minus infinity to minus 2, f of x is increasing, and in the interval minus 2 to plus 2, f of x is decreasing, and in the interval 2 to infinity, f of x is increasing again. So the answer to this is f of x is increasing in the interval 2 to infinity and f of x is decreasing in the interval minus 2 to plus 2. Next question is, consider the following optimization problem where f of x is equal to x power 4 plus 7x cube plus 5x square minus 7x minus 17x plus 3. Let x star be the maximizer of f of x. What is the second order sufficient condition for x star to be the maximizer of the function f of x? So here we find the first order derivative for f of x would be getting 4x cube plus 21x square plus 10x minus 17. When we differentiate it again, we would be getting 12x square plus 42x plus 10. So for the second order sufficient condition for x star to be the maximizer of the function, this second order derivative 12x square plus 42x plus 10 should be less than 0. So the correct answer is option 4. Next question is, in optimization problem, the function that we want to optimize is called as, the answer is objective function. Next question, the optimization problem, min x of f of x can also be written as max x of f of x. So this is false. The objective for min x of f of x is not equal to the objective for max x of f of x. So this is false. Next question is, gradient descent algorithm converges to the local minimum. So the answer is true. True is the correct answer. That's all for the answers. See you in my next video. Take care. Bye-bye.